I wanted to talk about Pop Quiz 2. So I just went through and graded everybody's work. And I kind of just wanted to make it a video to kind of explain the answers because I kind of felt like there's a few in there to where a lot of people got wrong. And I just wanted to kind of go over the answers just so that we're all on the same page. So I'm going to start off by going to the coding standards. Now, I'm just going to highlight some of the points that I want to talk about. So one of the points I want to talk about is variable names. So here I tell you that variable names should be something meaningful to like what the value actually holds. And then if you scroll down, I talk about constants. Okay, so this is where I saw a lot of problems in the quizzes and the homework. So what you need to do is we don't have any literal values. So we call magic numbers. So what we want to do is create a constant for that. So in this case that I gave you inside the coding standard, you're calculating the average and there's two tests. So instead of dividing by 2, you just divide by the number of tests. And you create a constant up here for that number. Now, if you continue to read, this is where people are making the most problems. And this is what I wanted them to read when I asked you to read the coding standards, is that you shouldn't actually create a constant for variables that hold input from the user or hold calculations. So really the constants are just anything that, or what we use constants for is anything that's a literal value. So like in an equation, when we use 2 or like some factor, then we want to declare a constant for that. So let's go ahead and go through the questions. So I'm going to scroll up and we'll start with question 1. Let me make this a little bit bigger. Okay, so the first question tells you, does the following comply with the coding standard? Now, if you look at this, what's actually wrong, and I'm going to go and just pull up, I went ahead and made the real programming examples. Okay, so here is a question, or here's the coding snippet that you got on question 1. So the problem here with this one is we're declaring this constant, okay, but we're using the same constant to hold input from the user. And if you go back to the coding standard and you read what I just have highlighted, you'll see that you shouldn't make a constant to hold user input. Okay, so that one should have been no, and the reason why is because variables that hold user input should not be constant. Now the next one, which is this coding example right here, okay, we pretty much have the same thing, except this isn't in all caps, which was designed to kind of throw people off. And the reason for this being wrong is for the same reason. You don't make something constant that's going to hold user input. Like what you should do is get rid of that final. Okay, so what makes a variable constant is the modifier final. Like once you put that final on it, it becomes constant. Now our coding standards tell us, okay, we're going to make a constant, make this all caps, but this is not a time to use a constant. So what you should actually do to correct this is just get rid of the final modifier, and this program is fine the way it is right now. So the next question 3 is right here. Okay, now for this one, this was a little bit of a trick question, I suppose. So if you go back to the coding standard, what I was trying to test you on is if you know variable names, where when you're making a variable, okay, you're storing data, you don't use underscores, you use what we call camel casing. So in this particular instance, okay, you should have said no, it doesn't meet the coding standards. And the reason why is because this is a variable that's holding input from a user. It shouldn't be constant, which is not, it's not declared as a constant. And you shouldn't use that underscore. So you should actually come down here and get rid of this underscore so that you can comply with the coding standard. All right, so question 4, I'm just gonna go ahead and hop over to the code example. All right, so if you look at question 4, which is right here, okay, this is the coding example that I gave you. Now, a lot of people, for some reason, said this was fine. There's nothing wrong with it. And then I saw things like, oh, this number times 2 should be constant. Num should be constant. Like these two right here are fine the way they are. And the reason why they're fine is going back to this spiel that I had down here under the constant sections where I said variables that hold user input or store calculations should not be constant. So if we go back to the code, okay, now the reason why this doesn't comply with the coding standard is because you're not supposed to have literal values inside of equations. Like we need to actually come over here and make a constant for this. All right, so that 2, like you should come over here and make a constant with final int, factor or multiple. We'll say like, and we'll just say 2. Oops, I'm sorry. This should be all caps. Dang it. So I'm violating the coding standards. Okay, and then we put a semicolon right there, and then we can replace the literal value 2 with our constant we just created. Question 5 was also a trick question, and I can see why a lot of people got this wrong. And I'm gonna have to go and update my coding standard so it's a little more clear of what the correct answer is for question 5. So in this particular example, I did declare a constant for 2, and I used 2. What makes this wrong is whenever we make variables or like identifiers, the name should be something meaningful to what that value actually is. Like there really is no point of making a constant 2 if you're going to name it 2, right? It's the same thing. It's like just using 2. What you want to use is like something meaningful to what that value actually is. What is a 2 in this case? It's the factor that we're going to multiply whatever number we get from the user by. So again, you can use multiple or maybe like factor or just something that represents what that 2 actually means instead of just using 2. Because when you use 2, it's just the same thing as just using the literal value 2. All right, so the next questions, let's see, question 5. All right, so this is where I kind of start testing you if you're watching the video. So like I'm getting like this really bad vibe from some of the students that you're not actually watching the videos. And it's just kind of disappointing because if we were actually meeting on campus, like 3 hours a week, we would meet and I would lecture. The lectures that I have on YouTube are lectures that I recorded in classes before. And that's exactly what I would have said. I would have just pretty much repeated myself. And it's up to you to make sure you schedule, clear your schedule so that you can actually watch the entire video, not just parts of it or skip around until you find something that, you don't understand. So you need to watch all of them. And I'm going to continue to do these pop quizzes, especially for chapter 4. Because I really want you guys to watch the videos for chapter 4. Now, grading these pop quizzes was kind of a pain in the butt because everything was essay questions. So I think maybe for the chapter 4 pop quiz, I'm going to ask you questions about the video, but it's going to be multiple choice. And I'm going to just try to concentrate specifically on making sure that you actually watched and retained information from the videos. So just be prepared for that. So the first question was, what example did the student cheat on? And it was a tree where you're making a tree. Some people, I wasn't really looking for the problem number. I know some people put 1.6, but it was just making that tree. If you remember, he used a for loop, and he did it crazy, right? Using the for loops. When I just took a sample of his code and pasted it into Google, I was able to find the exact same code on Stack Overflow. Question 7. Okay, this is where I ask if I demonstrated using the long literal, and I actually did that. So I showed you that using a lowercase l or an uppercase L in a long will actually make what we call a long literal. Otherwise, Java is going to treat it as an integer. Okay, so in chapter 3, I actually did a demo where I demonstrated all of this stuff. Okay, because these are normally the ones I demonstrated. I know from your book you also have the cosine and the arc. Cosine, arctangent, like all the trigonometry stuff. I typically don't demonstrate any of those, but from the actual video, this is what I demonstrated. Some of these aren't in your book, like these right here. This is what I want you to use whenever you need to use pi. You're going to need this for chapter 3 homework. Let's see. So also, whenever you do powers, you should use math.pow, and square roots, you should use math.square root. Like, you're going to have to use these in the chapter 3 homework. Okay, then I asked, like, which of the following did I talk about? So I actually, to be honest with you, like, I don't remember if I actually talked about secure random. Okay, I know I've talked about big decimal, but I don't know if I do that in chapter 3 or chapter 2. And then there is actually no class called unsigned integer, but I know for sure that I talked about everything else. Okay, so I just like I marked you wrong if you gave me unsigned int. You said I talked about it, or big decimal. But in all honesty, like I don't remember if I actually brought up big decimal inside of the chapter 3 videos. So actually, I'm not going to grade this quiz. I'm going to go ahead, like it was my first time doing a quiz like this where I'm asking you questions about the videos. I think I'm going to continue it because I just get that feeling like students aren't watching the videos. Like there is some students that couldn't answer this question right here. Okay, now if you actually watch the videos, like that was a pretty blaring time in the videos where I'm just, I kind of broke away from the flow of what I talk about. It was at the beginning of the class. I was really upset about it, because it's offensive to me when students try to cheat, thinking like I can't use Google and find the exact same examples. I can't go on Course Hero or the other one. Dang it, I already forgot what it was. But I know all of those sites. Just we get trained on all this stuff as instructors of where to look and test to see if our students are cheating. Normally, I don't go that deep into checking if people are cheating, just because I feel like if you aren't actually learning this material, when it comes time to my midterm, you're going to fail. When it comes to the final, you're going to fail. So I kind of feel like if it's not like a blaring case of cheating, I normally don't call people out on it. I mean, I know anybody can go get help from the tutor or ask somebody to help them with their homework, or just take the work that I do and put in Dropbox. So I'm not really going to dive that deep into checking if you're cheating. But if you're doing things where I know you don't understand and it just looks too advanced for what we're actually doing, then that's where I'm going to the red flag gets raised, and I'll go ahead and mark you for cheating, try to withdraw you from the class, that type of thing. The last one was whether I talked about math with hexadecimals. Now, I believe I showed you how to generate a hexadecimal and a binary string, but I didn't actually show you how to do math with hexadecimals. So I don't know if it was a trick question, but I mean, I believe I might have talked about hexadecimals, but I don't actually know if I did, or actually, I'm sorry. I do know for a fact I didn't do the math of hexadecimals. Okay. So like I said, this quiz is not going to be graded. I was just kind of curious to see which students are actually read and understand the coding standards. And I kind of feel like, maybe they weren't clear enough, especially with question 5. So I'm going to have to go back and update it. But what I wanted you to walk away from is that the only thing that should be made a constant is the literal values inside of your math equations. So input from users or a variable used to store the results of an equation, those should not be declared as constants. What makes a constant is this final modifier. Okay, now if that's still a constant right here, even though it's in lowercase, it's just a constant that violates our coding standard. All right, so I think that is all I wanted to talk about. So I'm gonna give you similar quiz for chapter 4 because I really want people to watch the chapter 4 videos. I think I'm gonna continue this where I ask specific questions about the videos so I can verify that you're actually watching them, especially for chapter 4, 5, and 6, because those are actually when programming gets really difficult and students have the most trouble.